Right, so we're going. Hey, how's everyone doing? Sorry, talking in through here, making sure everything's running okay here, and that we got my calculator running good. All right, and let's clear that out. So, hey, how's everyone doing? We're going to look at chapter 3, and we're going to start talking about probability. And so you're going to get something that you don't get too often here. You're going to see me talk for a second, so I think it's better that you see someone instead of not coming across. And so what we're looking at here with probability is we have to think about the nature of randomness and how random comes into play with the things we're doing. Now, we have learned descriptive statistics and how to describe a data set from what we observe. But what I want us to realize is that reality itself has a randomness to it, and that randomness is inherent into the things I do. 1 second here. Back around. So, I've got my lovely measuring stick here. There we go. And this has markers on it that helps me measure. And so if I'm observing reality, I can measure things out. But notice there's spaces. And so when I go to measure something, and I put the one end on it, let me flip it around so I'm near the zero. I come up here and I get near zero. And I come down to the bottom end. Notice it doesn't come to exactly to a point. And so, not exactly coming to that point, I have to make a guess. And so, what is it? That's 5 and a quarter inch? Or is it 5 and 0.2 of an inch? I don't know. I don't know the exact reality of the length of this pen. Now, I could go and I could get a laser, and that laser would measure the pen down to one wavelength of light. 540 nanometers, 300 nanometers, really small. Nanometers 10 to the negative ninth meters. And I can measure it down that close. But even again, I might be off by a little bit. And the pen itself is made of atoms. And those atoms are connected together and they're bouncing up and down. So when I go to measure this, when I go to get the value of the size of it, I might have gotten it when all the atoms were stretched out as far as possible, or when they're in together. And so the pen itself might have different sizes depending on the time I click that and make that measurement. And so all of these go into that there's no perfect measure of something. There's some randomness in the jiggly nature of the atoms. There's some randomness in how I measure and use my measuring device to minimize what we're going to call the measuring error. And all this comes together to say that I can never truly see the true size of the pen. I have some, but there is a true size. And so statistics' job is to help me observe the truth. But if I can never quite get to it, I have to somehow deal with all this randomness, the random vibrations of the pen, the random error in my measurements. And so I have to really right now study randomness to understand it. And then once we understand randomness, we're going to peel it away from the truth so that we can say, hey, well, I measured this, so I must be close to the truth because of randomness. So that's why we're doing probability. That's why we're doing probability now. We've learned to measure things. We've learned to observe things and to record them statistically. Now we have to take into account the random nature of just observing. So let me get back to my blackboard here. Here we go. And so we're gonna work with probability. And probability starts with counting. Now the people who invented probability, the people that worked this, they're interested in the concept of probability, but they also were starting the first people to really play a lot of gambling games. And so some things we're going to see come up is we're going to see a lot of examples using dice, and we're going to use examples using cards. Now cards are, and kind of, I think came from the Egyptian and the tarot that came across. And there are 52 cards, and they're divided into two colors. Red, which was the sun, and black, which was Newt, the night. And in the red, there were hearts for good health and diamonds for good fortune. And in the black, was clubs for strife or struggle, and spades for combination of death, because the spade's a digging shovel for death, and hard work. And so a club was like an instrument that people would be beaten with, and a shovel was something you used to dig. And so these two things came about, and so they were kind of like fortune telling. And then the cards themselves had an ace, a king, a queen, a jack, and then 10, 9, 8, 7, 6, 5, 4, 3, 2. No one. The ace plays the role of one and as the highest card. And so there were 4 aces. There was an ace of hearts, an ace of diamonds, an ace of clubs, and an ace of spades. There were 4 queens and so on. And altogether that gave us 52 cards. And so you're going to see this referred to sometimes when these people were inventing these rules for probability. They turned to the things they had, and they looked at cards and some of the things that could come out of cards. And also we're going to see dice. And now when I talk about dice, there are different types of dice. Let me see if I can get these to show up here. Again, I'm going to pop over here under the camera. 1 second. So everything's right out of reach back here. So when I go to grab something, I have to grab back. But so this is a typical die. It's a cube. There's 6 sides. But I also have a die that has 8 sides, 10 sides, 12 sides, 20 sides, and 4 sides. And so I can roll dice and do some random things with them. And so when I talk about a die, I will talk about the number of sides it has. The assumption is that there's one number on each side. And so I will sometimes talk about a die, in this case as being like, a D4 is a 4-sided dice. Or a D6, which is the standard 6-sided that you're used to seeing. And so for some of these examples, I'm going to have to use this nomenclature. So I'm just going to get it out of the way right now. And so what we're going to talk about is probability, sometimes known as the odds of things happening. And so when we talk about probability, we're going to call these things probability experiments. And probability experiments are one action or one trial I'll use the word one for now. We might modify it. One action or trial which produces specific results. All right, and this is on the slides if you're following through the slides. I'm kind of going to be talking about these. And so a probability experiment is we run some experiment and we get a result. An outcome is the result of a single trial of a probability experiment. Now, the next definition I'm going to use, I want to be very, very specific about how it differs from kind of how the words were doing before. So I'm going to switch colors here, and we're going to talk about the sample space. And you're going to note in this definition, there's going to seem to be a contradiction in word choices, but we'll bring it into a little more detail. And so the sample space is the set of all possible outcomes of a probability experiment. And I know when I say it in class, I see people go, wait a minute, but samples were a subset of the population and the population was all. You got to make a difference here between running a census where I count everything up, and a sample space where it's all possible things from which I can draw a sample. So, for example, if I were to count every American in the US, there's like 328 million of them. I'd do a census and I would get data on every single one. But that's not all possible Americans, right? There's future Americans to be born. There are the past Americans that could be. A sample space is all of those things from which I could draw from. And we'll see it clearly when we start defining them in terms of our dice and such, and our different probability experiments. And so I'm going to go brighter here. Let's go brighter. That purple always comes out light for me. Hey, yeah, we're coming through here. Yeah, good. We'll do an event. And this is one or more. Oops. Not like iron ore. Or more. One or more outcomes. And so this is a subset of our sample space. All right, I'm going to use a six-sided die as my first example of this. And we're going to borrow a lot of the notation from sets as we do this. But what we'll do is we'll say, hey, I have a six-sided die. It's possible for a six-sided die, all the outcomes I can have is I can roll a 1, I can roll a 2, I can roll a 3, I can roll a 4, I can roll a 5, or I can roll a 6. And so this is my sample space on a D6, right? On a six-sided die. I can roll 1, 2, 3, 4, 5, 6. That's all I can do. And so I can talk about an event being I roll a 1. Now let's say roll a 3. I roll a 3. That's one outcome from that sample space. Another event I can have is rolling 4 or greater. So I can roll greater than or equal to 4. And notice 4, 5, and 6 would be the possible outcomes. That's one event, rolling greater than or equal to 4, and there are 3 elements in my sample space. And another event I could do in this is I could say an event of rolling an even number. And so there are different events that can come out of a sample space. And so the sample space is all the possible outcomes. Something that isn't in my sample space is rolling an 8, right? I cannot roll an 8 because it's not in my sample space. It's not a possibility. Now, I could roll multiple times and still draw from my sample space. The sample space is all the possible things that I can get every time I try to run this probability experiment. All right, well, let's look at another aspect of this that we can look at. And I'm going to use the example from the slides, which is that people can have a blood type. They have a blood type that draws that are either going to be type O, type A, type B, or type AB. Now, of those, they can be Rh negative or Rh positive. So if I were to randomly pick human beings and test their blood, my sample space, my possible outcomes of those tests would be, well, let's build a tree. They could be O, A, B, or AB. And then subsequently, that could be plus or minus, plus or minus, plus or minus, or plus or minus. Now, if I look here, there's 1, 2, 3, 4, 5, 6, 7, 8 outcomes that are going to be in my sample space. And for lack of better notation, I'll write it as O positive, O negative, A positive, A negative, B positive, B negative, AB positive, and AB negative. And so I've now made the sample space for a random blood test. I could do a random blood test, and my sample space or my outcomes would be drawn from that sample space. All right, I'm going to put up this video on sample space, and then I'm going to talk about events next.